Okay guys, we are going today to learn about the application of trigonometry. Yeah? In this term we have learned about everything about trigonometry, about the rules in the trigonometry, about identities in the trigonometry. Now, how can we use this knowledge in our daily life? Yes, as you know, the trigonometry is a branch of mathematics that studies about the ratios of the sides of a triangle. Yeah? That means from the given elements of the triangle, we can find the unknown elements of the triangle. Yeah? This is the two theorems, you know, a sine theorem, cosine theorem. Here, if there is given this two sides and the angle between these two sides, we can find the third side with the help of what?
Another side.
This one. This theorem is cosine theorem. Yeah? Okay, now, and also, let's try to use this and solve the exercises. Here we have, now if then, as you see, if we know, how can we use the trigonometry in our daily life? For example, this is a tree, yeah? We want to measure the altitude, height of the tree, and if the angle, we know we can measure this angle, this is the angle of elevation, and we can measure the length here, this is just distance, and we can find the height. How? With the help of which formula? Sine? No, tangent formula, yeah? Opposite or adjacent. Yes, tangent theta is equal to h over x, yeah? That is tangent, now, x is given, and theta is given, we can find the height. And also here we can find the length of the this building, yeah? The height of this building. Okay, what about this one, mountain? We want to, it's very big, very, very big. How can we measure this? With the help of, we can calculate this with the help of trigonometry, yeah? This is 2 points, where in 2 points we are going to measure the elevation, angle of elevation. It's 30, at this point is 35 degrees, at this point is 30 degrees. The distance between these 2 points is 1,500 feet. Okay, then, is this possible to find the height?
Yes.
Okay, let's try. This point is 35 degrees and this one is 30 degrees. This length is what? 1,500 feet. X. Okay, we can solve this. Okay. Thanks. Okay. Thanks. Just we have to find the sine theta, yeah? We have to find
Firstly, to know the height, we must find this hypotenuse of this triangle.
yes.
To find the hypotenuse, we need the angles. This angle will be equal to 145
degrees.
and this angle will be 5 degrees.
Together 180 degrees, yeah?
Yes. Then we can, by the sine theory, which denotes a length of side A
Yes.
over sine of opposite angle
Yes, sine of opposite angle.
is equal to length of side B over sine of angle B. And
see.
Sine. So 1,500 feet over sine of 5 degrees, it will be equal to y over sine of 30 degrees.
Okay, now let me help you. Sine of the 5 degree is what? 0.087.
And sine of 30
is
is 0.5.
0.5, yeah?
By calculating, we can find y. It will be equal to
Yes, now 1,500 divided by 0.087 and multiplied by
0.5.
1 second. 8,600 620.
Then we know that sine of 35
Sine of 35.
it will be equal to x over hypotenuse. Why? Why we know inside 35 we can find
Find
by calculating.
It's sine 35 is equal to 0.57.
And x over that is equal to
Okay, now we are 0.57 times 8,620. It will give us 4,944. Yes, this is feet, yeah? And this is the height of the mountain, yeah? Okay, thank you. 1 minute. Thank you, sit down, please. Okay, now if you with the given two information, 35, 30, and the length, the third one, the distance between, we can find the length of any building, yeah? Mountain. We want to find the length of this building, the height of this building, and this is the point where we stand, C, and between us and the building there is a lake, yeah? We can't pass that. Okay, now, but we can measure the angle of elevation. This one is 32, 34, and we can, now here we are just going to provide a line, a rope, yeah, that will be perpendicular to this line that joins us with the building here. And then here at the point D, we know the length of this one, 30 meters at the point D. We are going to measure this angle. The angle between this line and the line which joins the point D with the building, yeah? That angle is 63 degrees. And what? Now this is given, we measured this one, 63 degrees, this one is 34 degrees, and the length of this one is 30 meters. How to find the length of the building? Anybody? Okay, so come here. Now that's easy, yeah?
yes.
So now, in the door. Okay, first thing we have to do is just find the what?
We just must find the distance from the point where we send to the building.
Is from the point C to the building, yeah?
Yes, we can know it by the using of tangents, because we know the edges inside, and we just must find the opposite.
Yes.
So, tangents of 63 degrees is
Yes.
approximately 2. So, 2 is equal to x, which is the distance to the 30 meters. From here we can know that distance will be equal to 60 meters.
Yes, that's correct.
Second thing that we must do is just also by using tangents, but now of 34 degrees.
Yes. Tangent of 34 is 0.67.
So here's the opposite. The opposite for this angle is the length of building. 0.67 equals to length of building divided by the 60.
Yes, that's correct.
So length of building will be equal
40.4. 40.4.
meters.
Yes. 40.4 meters. Okay, then thank you. Sit down, please. Then the length of the height of the building is 40 meters. Yes, it's very high. Yeah. Okay, now another example. Okay, the similar example to the first one, yeah? We can solve this. Anybody? Oh. Okay, thank you. And here. Here.
We have to find height. In order we can take this side as x and this side as y. In order to find height, we have to know hypotenuse. And in order to know hypotenuse, we have to find degrees. So this angle will be 138, and this one is 12. By using a sine theorem, we can find length of hypotenuse.
Yes.
It will be 10 over sine 12
Sine of 12, yeah?
equal to y over sine 30.
So
We
that
get
is
10 over sine of 12 is 0.2
0.2, yes.
is equal to y over 0.5. From here we get that y is 25 is equal to 25.
Okay, thank you. Then,
So now we know hypotenuse, and in order to find height, we know that we know this thing. Sine is equal to hypotenuse or opposite over hypotenuse,
Ah, yes, hypotenuse, yes.
and sine of 42 is x over 25. Sine of 42 is 0.7.
Yes.
So x over 25. From here we get that x is equal to 17.5.
Okay, thank you so much. That's correct. Yes, it's very easy, yeah? And it's very useful. In our real life, we can use this, yeah? To find it. Okay, now the next here, other application of the trigonometry. Also, we can find the measure between our moon and our earth, yeah? To do that, we have to, at the same time of the day, we have to measure of the angle, inclination of the angle of the moon from the horizon, yeah? Horizon. And after some calculations, we can find the distance between moon and earth. It's not so difficult, but we can do that, yeah? And also, the trigonometry is used in the physics and everywhere in our life. For example, in the representing the waves, sound waves, and light waves, we use the trigonometric function, sine function. Yeah, we represent that with the sine function, as it's what periodic function. Yeah, waves are periodic. That's why we use the sine function. Now, as here, as you see from the graph, as the difference between this one, the amplitude is what? Is a bit longer, yeah? If as the amplitude is longer, no, altitude is longer, then the sound is louder. If it's smaller, then the sound is quieter, yeah? And also the sine trigonometry used in the navigation systems. Like to find the direction, to find the distance between two locations in the earth. In the physics, you know this? What is this? Yes, this is Angry Birds. You have played this, yeah? It's very interesting game. In this Angry Bird, this game, what the projectile motion is used, yeah? You know the projectile motion from the physics, yes. And do we use it in the trigonometry?
Yes.
To find what?
Direction.
Yes, to find what? Now, for example, if we have the velocity, to find the horizontal Vx, we use sine. We multiply that with cosine alpha, yeah. And if we to find the vertical, now Vy with sine y, yes, that's correct. And also in the optics, in the physics, it's used. Now this is our human eye, visual angle. This is the visual angle that we see. And if we know the height of the object that is apart from us, and the distance between us and that object, we can find the visual angle just with the help of this formula. Yeah? Okay, let's show you. Okay, now visual angle. As you see, this is our eye. This is our eye. As we know the length of this BC. As the length of the BC, we know the length of the BC. This is the visual angle. Yeah? We can multiply the AD, the distance between us and the object, with the help of this formula. As we increase, as the decrease, as angle is increasing, the object is getting closer. Yeah. Maybe our eye, senses in our eye, get this information that angle of the visual angle is getting larger, and sends that to our brain, and our brain what analyzes that the object is getting closer. Yeah. And also we have how many eyes? Two eyes. Yeah. How do you think?
To
Because of what?
see 3D
To see.
What?
in 3 dimensions.
Yes, 3D dimension. Yeah. We want with 2 eyes we can see that objects in 3D dimension. That means depth of something. Yeah. For example, depth of this one. Yeah. And if we had just 1 eye, we couldn't see that. We couldn't know that which one is closer. Yeah. As we have 2 eyes, we can say that this one is closer. Yeah. How that process is going? Let's try to understand it. There is a theory that tells about the reason that we have 2 eyes. Scientist says that because of the different images that we get from 2 different eyes, we have the 3D effects. Yeah? Okay. As you see, here we have 2 eyes. This is an object. This is when we close the left eye, see with the right eye, we see this object. We don't see anything here. Yeah. Yeah. This part we don't see. We don't see. Yeah. This is we can see this green line. From this point to here, we don't see with the right eye when we close the left eye. Yeah. And the same thing if we do that with left eye, close this right eye, and look from the left eye. We see this object. We see this part, and from this point we don't see to here. Yeah. And here is the difference. Then this is the part that our right eye doesn't see. This is the part that our left eye doesn't see. This is the differences between 2 images. Okay, as you see from this here. Yeah. If we do this experiment, as you see, this is left eye what sees. This is the right eye, the image of what the right eye sees. Yeah? And if we just now, if the difference between these 2 images that we get increases, that means the object is getting closer. Yeah?
Yes.
If the image between these 2 eyes decreases, the difference between this decreases, that means it's getting now apart. Yeah, from us. Okay, then. Okay, now also trigonometry we said used in navigation system. Nowadays we have our human body developed navigation system like GPS. Yeah, you know, GPS systems. We use that in our mobile phones. They're used in airplanes, in such a lot of areas. Yeah, this navigation system uses it. Okay, but in the history, from where this navigation system began? The scientists used to find the direction to some location, to find the distance from one point to another point in the world. They used trigonometry. There's a special type of trigonometry that is called spherical trigonometry. Okay, before that, let us watch this small video about everything that we learn from the animals, we learn their tactics, we will learn, for example, radar system. You know the radar, yeah? In the plane, this is used. In the ships, this is used. This radar system inspired from the bat. You know the bat? Which has eyes but don't see with his eyes. Yes? They get echo, now sounds. This bat sends a sound and gets the sound, and it has in his brain a radar system that can freely fly. Yeah? Okay, now that means this we are the humans inspired from the animals. Yeah? That's the issue.
To move, navigating the first of millions of miles, spanning continents on fledgling wings, clattering ever onward. Right now, our planet is on the march, on the wing, on the run. And these are the tales of its creatures, the stories of the great migrations.
Birds are migrating, yeah, flying.
The plains in the shadow of the rift, the Serengeti, are threaded with the paths of the millions on the move in a constant burning search for fresh grass. Every year, more than 1 million wildebeest and 200,000 zebras must chase the seasonal rains in a 300-mile loop around Tanzania and Kenya. But here in the Serengeti, they pause. Like the crabs, creatures around the globe are moving to the music of the spheres. They register the sun, the moon, the Earth's magnetic field, and move at their bidding. Even the navigational feats of the most delicate of creatures dagger the imagination and confound our understanding. And in tiny slices of endangered Mexican forest, hundreds of millions of the world's most astounding navigators are stirring. These monarch butterflies have waited patiently through the winter, barely moving, for the sun to tell them it's time. Masses take to the wing, heading to a place they've never been. Their only map imprinted on their genes. Mysterious interplay of sun on eyes and antennae. An uncanny sense of magnetic north guides the way. It will take 5 months for 3 generations to get the species as far north as Canada. And a 4th super generation to get them back to Mexico. Such a multi-generational migration is incredibly rare. It takes the leading generation 3 weeks to fly 500 miles into the southern U.S.
It's very interesting, yeah, isn't it?
Yeah.
Monarch butterflies fly through the America from the Mexico to the Canada, yeah? And they do this in 5 months. Do you imagine that? 5 months. And only the fourth generation can reach that. Third generation can reach that. Canada and the fourth generation come back to the what? Mexico, yeah, Mexico. And also we have the such birds like golden plover, which flies from the Hawaii to Alaska. That is approximately 4,000 kilometers with non-stop flying. It's very interesting. Yeah, we don't know about how they find the direction, how they for example, calculate their energy. Yeah? For example, if our plane, for example, can fly only the fixed kilometer, yeah? But that we know that kilometer. But how these golden plover birds know that distance? How they know that how much they have to fly? Yeah? We don't know. Humans couldn't know till these days couldn't find the answers for these questions. Very interesting navigators they are, but we are today try to find the answer to try to understand about the basics of our navigation system. Yeah? The basics of our navigation system is start from the spherical trigonometry. This is the one part of the trigonometry that studies about spherical triangles. The spherical triangles are the triangles which are formed with the help of three big circles. This big circle is a circle that cuts the this one sphere, and the center of that circle is on the sphere, on the center of the sphere. Okay? Here, this is the one example of spherical triangle. Is this clear? Okay, now we are here. Let's try to understand this. Now, do you see this? Okay, this we have the three big circles. These are called big circles with the center the same with the center of the sphere. And these three circles, big circles, intersect at 3 points and form this triangle, which we call spherical triangle. Okay, now the spherical trigonometry is about this triangle. How to find the unknown element with the given information. For example, if we know if the this is an arc, yeah? Arc has the measure. We measure the arc in degrees, yeah, or in the radians. The measure of the arc is same with the measure of the central angle. Okay. Now, then, if we know the measure of this arc and the measure of this arc and the angle between this one, 85, can we find the measure of this arc? Yes, we can find that with the help of cosine theorem for spherical trigonometry. Now, we know the cosine theorem for plane trigonometry. Yeah? Now we are going to understand how this cosine theorem looks like in spherical trigonometry. Okay, now, is this now the three spherical triangle which formed with three big circles? Yeah. And now the length of, let it be, length of the arc is c. Now here we have three vectors. Two vectors here and the third one here. Yeah. One vector we provide a line from one vector. This is OA. That will be the z-axis. And now another second vector, let it be. We will choose a plane that passes through this vector OB and OA, and we will denote this plane as XZ plane. XZ plane, yeah. That means this vector lies on the XZ plane. And if this vector OA lies on the Z axis, then as it's this sphere is unit sphere. The radius of this one is 1. Then the coordinate of the vector OA is 0, 0, 1. Yes? From some calculations using the trigonometry here, we can find the coordinate of the B. as you see, the second component is y component. Yeah? It's 0, yeah? Because the OB lies on the xz plane. That's why y is 0. And we can find the, now here x component is by multiplying this on c, the length of this 1, yeah, multiplied by sine c, sine of this one, will give us opposite side, which is the coordinate of the x coordinate of the OB. And in such way we can find the cosine c, and also we can find the components of the OC with the help of this arc and this angle, yeah? And that we will have these three vectors, OB, OC, OA. Now you know that to find, from the vectors we have learned about the vector product, yeah? How many formulas for the vector product we have? Two formulas, yeah? One with the cosine angle between them. The second one with just multiplying the satisfying components, yeah? The first one, OB times OC, that's length of OB, 1, as its unit sphere, yeah? And 1, OC, the length of the OC is 1, and the cosine of the angle. Cosine of the angle between OB and OC, that's A, this one. Red arc, yeah? Is equal to sine C, these are the, by the second formula, the first component multiplied by the first component, second component 0 multiplied by second component, and third component here, this one cosine C multiplied by cosine B, yeah? Here we will get a formula, this one, cosine of the arc A, cosine of this arc, is equal to cosine of B, this arc, cosine of C, this arc, and plus sine of B, sine of C, times of cosine of the angle between these two arcs. Is this clear?
Yes.
Okay, now, then this theorem is called the cosine theorem or cosine rule in spherical trigonometry, yeah? And also we have the sine theorem from the squares, you know that the squares of the sine and the cosine for the same angle is equal to what? Is equal to 1, yeah? Sine square alpha plus cosine square alpha is 1. By using this theorem, applying the to cosine this one, the right side of the here, we can find the sine theorem. Sine theorem for spherical trigonometry. This one is the sine theorem for spherical trigonometry. Okay, the both of them are used to find the first one. We will use this one to find the length, direction, distance between 2 points. The second one we just use to find the angle, direction. Yeah? Okay, now how do we? Let's, for example, if we have here now to find that we have to know about the spherical coordinate system. From the geometry you have learned about the meridian and the parallels, yeah? You know that?
Yes.
What is this basic parallel? Equator, yeah? 0. Equator is 0. And you know that what is the prime meridian? Yes. The meridian that passes through the Greenwich, yeah? Through the Greenwich is 0. And as you see, when we look to this map, we see here the numbers with what degrees, yeah? What these degrees mean? Okay, these degrees mean, for example, if we have 20 degrees, this point is 20 degrees to the north, east 20 degrees to the north, yeah? That means here. Or this is the point C. This is 20 degrees means this angle to the east, yeah? 20 degrees to the north is here, the angle between these two vectors. Is this clear?
Yes.
Now if the coordinates of the, for example, let us try to find the distance between two cities. These are Astana and Almaty. Now the coordinate, so Astana and Almaty are given. They are 51 degrees 1 minute 52 seconds to the north. This is the what? latitude, yeah? Latitude, 71 degrees 25 minutes 40 seconds to the east. This is the coordinates of the what? Astana. This one is Almaty. Let's first we have to write in here this coordinates in degrees. That's in decimal, yeah? Okay, now then 52 over 60 will give us the minute plus 10 minutes is equal to this one over 60 will give us 1.8. Then Astana has the coordinates 51.18 degrees to north, yeah? This is the latitude. And what? 71. This is 40 over 60 plus 25 is equal to over 60 is equal to 71.42 degrees to the what? East, yes, that's clear. Almaty has now 15, it's in minutes, yeah? We will divide it by 60 to find in degrees, and plus that 42, 42, 43. That's 43.25 degrees to north, yeah? Okay, now, what? 76, no, 57 over 60 is equal to plus 76. That will be 76.95. 76.95 degrees to the east, yeah? Okay, now we are going to calculate this. And now here, this point is Astana, and this point is Astana, yeah? Let it be Astana, and this point is Almaty, yeah? Almaty. And to find this angle, C, it's just this angle is C, yeah? We know the what latitude of this point? Latitude of this point is what? For Astana, it's 51.18, yeah? Just the angle between these two vectors. To find this angle, we just have to subtract that from the 90, yeah? That's gonna be, that's this one. Let's see, let me see. What? 38.82, yeah? This one is 80. What about B? Now the RP is just 90 subtracted what? The latitude of the Almaty, yeah? Latitude of the Almaty is what? 43.25. This one is going to be? 46.75 degrees. And what about the angle between these two vectors, two arcs? This one is just the difference between the longitudes. That's going to be yes, 5.50. Yes, we know that. We have all given information that helps us to find the arc A. Yeah? Now we're going to substitute to here. Cosine of A is equal to cosine of B times cosine theorem, yeah? Cosine of C plus sine of B times sine of C and times what? Cosine of the capital letter A. Just substitute all of them to here. We will have this one. The cosine of A is equal to 0. Cosine of B is here. Is going to be 46. Cosine of this one is going to be 0.77912 times 0.868518 plus then sine will be 0.62688 times 0.7272837 times the last is the cosine of A is 0.99535. Okay, here from here cosine of A, when we calculate this, we will get 0.98832. And here we can use the inverse trigonometric function, yeah? Arc sine, arc cosine. Arc cosine, by using the arc cosine, we can find the angle alpha, angle A. That's going to be 8.7656, yeah? 56. This is A. Now we know the arc A. This one is arc A, which is 8.7656 degrees, yeah? Now, this is arc A. Can we find the length of this arc? With the help of the arc length formula, we can find the length of that, yeah? That's gonna be what? The circumference of this circle. What is the circumference of the circle? Yes, 2 pi r, which this is the circumference of the Earth, yeah? We know that the circumference of the Earth is 4,077.16 kilometers. It's on the equator, yeah? It's on the equator. Then we are going to use this 40,077.16 and multiplied by 8.7656 and divided by 360. This is going to be 975 kilometers, yeah? 975 kilometers. 975 kilometers approximately. Approximately this is 975. Actually, the distance between Almaty and Astana is 972 kilometers, yeah? But this one is actually approximately. Why? Because as you know that our Earth, the shape of Earth is not spherical. Yeah? We call the this is called geotic. Yeah, geotic. That means Earth-like shape. For that reason, this is we found the approximate what distance? Yeah, this is 604 miles. Each mile is 1.6 kilometer. If it's multiplied, it's approximately 975 kilometers between Almaty and Astana, our capital city. Okay, now how can we using here the trigonometric? How can we using here what? Find the angle, direction. That's also easy to find the direction, to find the angle. This angle, for example, yeah, or this angle. We use the sine theorem. Do you remember that? Yes. Sine theorem. Okay, now then here we have. Now let me give you homework. Okay. Let me give you homework. Okay, write down this. This is Petropavl, our city, and this one is Istanbul, city of Turkey. Yeah. These are the coordinates. You can get that from the internet. And you have to find the distance between these two cities. Okay, now in the history, scientists used that these just calculations to find the length, to find the directions. Yeah, but nowadays we have just the GPS system, navigators that can easily find us the distance between 2 points, yeah, or direction. Okay, now we are human body just to find the navigation, to find direction. We use just a lot of these calculations. Yeah, we find the rules, we find the formulas, and put this system, navigation system to navigators. Yeah, to airplane. After that, we construct airplane to put to their navigation system. With airplane, we just can go from one point to another one. Yeah. But in the birds, this system is located, yeah? But we don't know how they navigate. This is very interesting. People are trying to find the reasons, to find how they fly, how they navigate, but nowadays we couldn't find. They are very perfect. Okay, then what also here? Let's try end our lesson with this. Okay, guys, let me read you what Einstein said. Before that, what Galileo said. Galileo said, the universe is a big book that is open to us. The big book that is open to us. To read this book, we have to know the language of that book. Yeah, isn't that? What is the language of that book? Science. Galileo said that it's mathematics. The symbols of this language are the triangles, circles. If we know the rules for these triangles and circles, we can read this book easily. And Einstein said that the most incomprehensible thing about the universe is incomprehensible thing about the universe is comprehensible. That means the most ununderstandable thing in the universe is that it's understandable. Is this clear?
Yes.
That means everything in the universe can be understood. For example, we try to just find the reasons how they fly, how they navigate, and after that we use these systems in our technology. Yeah? For example, like in bats radar, we use that in airplanes, in radar systems. Yeah? And that's why the language that's written, the universe that's written in language, which is mathematics, is very, very important. Yeah? Maybe it's very hard, but with the help of mathematics, we can find our calculations, yeah, our way. Now then, also we have in this universe we have the rules, like as you say, calculating here. This is a rule, yeah. For example, cosine for 38.82 for any angle, for any triangle with angle. For any right triangle with angle 38.82, this rule is correct. Yeah? Just adjacent side to the hypotenuse is constant always. Yeah? This is constant. Because of this constant, we can make the calculations. If it's not constant, we can't do the same rules to other areas. Yeah? Is this clear?
Yes.
Okay. Now, also with the help of the circumference of the circle, we can find the arc length. That means, you know the pi number pi? What is the pi? It's equal to 3.14, yeah? That means pi is the ratio of the circumference to the diameter. For any circle, it doesn't matter how it's big, yeah? The circumference, the ratio of the circumference to the diameter is always constant p 3.14, yeah? with this rule, constant rule, we can find the calculations, yeah? Okay, thank you. Everything is clear, yeah?
Yes.
You have to do the homework, and also one more project I'm going to give you. We said that we can measure the what? Distance between the moon and our Earth, yeah? How it's possible? You have to think, you have to search in the internet, yeah? And find the answer to that. Okay? And also, each of you have to find the length of a building, for example, near your home, for example, it can be, yeah? With the help of these calculations. And also, the last homework was to find the distance between Istanbul and Petrograd. Okay, thank you. It's over.